All right. Hi, everyone. This is Jim and part of the multi-tenancy working group. Today is January 11th, so we're having our first session of the new year. Welcome, everyone. And I think we had a couple of items on the agenda. So Charles is going to present Kubezoo multi-tenancy solution. So that was the main item. And then based on time, we will discuss a continuation from something we talked about back in November, which is creating a GitHub issue and next steps for Kubernetes documentation updates for multi-tenancy. Anything else anyone wants to add to the agenda for today, or anyone want to quickly introduce themselves, or any other questions or general topics before we dive into these?
I guess I could introduce myself. I'm a new person.
Yes, would go ahead, please.
Yeah, so my name is Mac. I work for a place called the Renaissance Computing Institute. We're associated with the University of North Carolina. I think we run what we believe to be the largest Kubernetes cluster in the University of North Carolina school system, and it's multi-tenant. So
Okay.
this meeting and this group is very interesting to me. Yeah, that's it.
Fantastic. And I know you've contributed already to benchmarks and a few other things, so thank you for the contributions and glad to have you join us.
Yeah, glad to be here.
Maybe I also introduce myself. I'm Eric. I'm located in Oslo, Norway. I just get aware of this community and the HNC, which kind of took my attention. So I just here to kind of see what you're doing, and I discussed a bit with Adrian on Slack about we might do some contributions to HNC.
Why don't I introduce myself then, especially for the new people. I'm Adrian. Eric, nice to meet you as in person as we're going to get these days. I'm joining from Toronto, Canada, which is where I live. Sorry, admitting people. And yeah, I'm the original author of HNC and the maintainer. And I apologize that I haven't been super on top of responding lately, but I'm trying to catch up again because there's a bunch of people who want to contribute, especially when it comes to propagating annotations and labels. And so this has been a popular topic, and hopefully we can make it happen even before, possibly before 1.0 at this point. So we'll see about that. No promises yet, but let's see if we can make that happen. Why don't I nominate Faye to introduce himself next?
Sure. This is Faye. I've been working in the multi-tenancy working group for a few years. I'm tech lead for the project called a virtual cluster, so which is another way of handling the resource isolation requirements for multiple tenants with statically control plan. So, yeah. Jim, do you want to introduce?
Yeah, I already introduced myself briefly, but I'm Jim Begladia, working on benchmarks within the multi-tenancy working group. I'll also do some work with the policy working group and on the Kubernetes project. Anyone else want to introduce themselves? And I see Tasha is joining as well.
Hello.
Hey, Tasha, how are you?
Good. How are you?
All right. Yeah, we're just kind of quickly doing a round of introductions for some of the new folks who are joining. And I think we had two topics on the agenda today. So Charles will be presenting on Kubezoo. And then if we have time, we can quickly discuss the next steps on the creating a GitHub issue for the Kubernetes docs update from multi-tenancy.
Shall we get started?
Yes, with that, Charles, all yours.
Okay, great. So let's get started. Before that, do you know how to share the screen or share the slides to the Google meeting? I didn't use it before.
I think there's a up arrow at the bottom, like
Present now, right?
yes.
Okay. Could you see the slides?
Yep.
Yep.
Okay, great. Hello, everyone. Thanks for joining. I'm Charles, software engineer at ByteDance TikTok. So today I will introduce our project, Kubezoo, a light gateway server that supports multi-tenancy on Kubernetes. Just give me 1 second. Slides. Okay. So here is an outline of today's talk. First, I will briefly introduce the background and explain why we want to have another multi-tenancy solution. Then I will describe the basic idea of Kubezoo. After that, we can discuss some of the implementation details, like how Kubezoo provide an illusion to each tenant that they are the only user of the cluster, how we categorize different Kubernetes resources and convert them respectively, and how we address some of the common challenges in the multi-tenancy scenario. Finally, I will run some demo case to show how we can use Kubezoo to achieve isolation between tenants and how to deploy a basic controller on Kubezoo. Okay, let's get started.
We lost your screen share.
Oh, you lost my screen?
Yeah, can you just reshare it?
Sure. What about now? Could you see the screen now?
Yes.
Okay, good. Okay, so why we come up with this project? As we all know, native Kubernetes only provides very limited multi-tenancy support using namespace, and the default mechanism cannot meet our requirements. So it is very common that different tenants or end users wanted to use cluster scope resource like cluster role, namespace, persistent volume, etc. While granting tenants the priority to use the cluster scope resource may result in tenant information leakage and other security problems, like malicious tenants may delete or update resource not belonging to them. Therefore, we need a solution or tool to help us to manage the Kubernetes cluster that are shared by multiple tenants. But why we don't choose some existing multi-tenancy solution? The reason for this is very simple, because in our case, we usually need to manage a shared cluster for a large amount of small tenants, while existing solution normally require us to provision independent control plane or cluster for each tenant. Let me give you a more detailed explanation of the small tenant here. So in our case, a typical tenant usually creates only couples or at most dozens of pods and use them for just couple hours. And sometimes there may exist thousands of this kind of tenants on a cluster at the same time. Since most of them only create a small amount of resource, creating independent control plane for each of them can be inefficient. In addition, our tenants usually require short turnaround time. That is to say, after they submit a cluster provisioning request, the cluster have to be ready in seconds or no longer than a minute, while creating a new cluster or control plane from scratch may take more than a couple minutes. Finally, the cluster or control plane level isolation may be an overkill. The operational and the maintenance burden for managing thousands of control planes or independent cluster can be heavy, and we all wanted to make sure that the SRE team is happy. So therefore, we come up with Kubezoo, a lightweight gateway server that supports multi-tenancy on Kubernetes. The basic idea of Kubezoo is very straightforward. So Kubezoo will act as a gateway server, sit in front of the Kubi API server, capture API requests sent from the tenant client, inject tenant-specific information, forward the request to the backend API server, and later process the corresponding response before returning them back to the client. So different from a normal gateway server, Kubezoo itself is an API server, so which is built on top of the Kubi Gateway Runtime Builder. The Kubi Gateway Runtime Builder is another project we are currently working on, which shares the similar idea with the API Server Runtime Builder, but differ from the aggregated API Server built by the API Server Runtime Builder. The Gateway Runtime Builder will build a Gateway API Server. We come up with this project because we found in everyday task that when managing Kubernetes cluster, we usually want to customize and the authentication or authorization policy, add extra admission handlers, share traffic, shard traffic, and route requests to different backend clusters. Anyway, I will not talk too much about the Kubi Gateway runtime builder here. For now, we only need to know that Kubezoo itself is like a Kubernetes API server, and with an extra cluster resource, which is a tenant resource. And there is a metadata store affiliated with the Kubezoo server to persist the tenant information. The metadata store can be etcd or any other KB store that support multi-version concurrency control. So as we mentioned before, we want to have a multi-tenancy solution that can provide good isolation between tenants, which provide an illusion to each tenant that he or she exclusively occupy the cluster and can safely use cluster scope resource while not bring any potential security issue. We also want the solution to be resource efficient, lightweight, and fast. Finally, we want to ensure that it will not import heavy operational or maintenance burdens. So how Kubezoo meets all these requirements? For the tenant isolation, how client operate the resource on a Kubernetes cluster depends on what they send to the cluster. And what clients see about the cluster depends on the response returned to the cluster. So Kubezoo server as a gateway server capture all tenant API requests sending to the backend API server and all corresponding response returning from the backend API server by injecting tenant-related information to the request and filter out unnecessary information in the response. Kubezoo ensure that tenant will not operate resource not belonging to them and can only view their own resource. In addition, after a new tenant created, we don't need to boost any extra components or parts. Instead, we only need to create the tenant object and sync several system resources like system namespace and cluster role to the backend cluster, which makes the tenant provision process super fast and light. Finally, as a unified gateway server, Kubezoo will be shared by all tenants. Therefore, it only requires a little extra computing resource and maintenance efforts. Kubezoo is not meant to replace any existing multi-tenancy solution, but more of a supplement to existing multi-tenancy toolkits. As we can see in this figure, we can divide multi-tenancy solution into 4 layers. From the bottom up, we have cluster as servers, which create independent cluster for each individual tenant. This solution has the strongest isolation, but has relatively lower resource efficiency. One level up, we have the control plane as servers, which provides very good isolation as well, since each tenant exclusively own a control plane. But at the same time, we have to pay the cost of maintaining and running control plane components. And then we can have a new layer called Kubernetes API servers as servers, API as servers. That is what Kubezoo aims to provide. It provides a view level isolation that makes an illusion to each tenant that they exclusively occupy the cluster. It may not provide isolation as strong as previous 2 solutions, since all tenants share the Kubezoo server, but it does not require too much extra maintenance efforts and is more resource efficient. Finally, on top of them, we have the default namespace as service. As we can see that there exists a trade-off between the degree of isolation and the agility. For a given solution, the stronger isolation it provides, the less resource efficient and the heavier maintenance burden it will be. But with all these potential options, we can choose the best solution that fits different use case perfectly. Here is a diagram that compare above approach from 5 different dimensions. The first factor we consider is the resource efficiency. Since all tenants share a Kubezoo gateway server, only a couple extra CPU cores or gigabyte of RAM should be enough. For the same reason, the operation cost is low as well. Since for each new tenant, we only need to create a tenant object and a couple system resource, the bootstrap time for each tenant servers is negligible. For an API compatibility, I will talk about it later. Currently, Kubezoo support most of the Kubernetes API except some features like webhook, which we plan to support in the near future. The tenant isolation provided by Kubezoo may not be as strong as control plane level or class level solution, but in our case, it should be good enough. Next, let's talk about how Kubezoo work internally and how we address some common challenges in the multi-tenancy scenario. First, let me introduce how Kubizu manages tenants. As mentioned in the previous slides, Kubizu itself is like an API server, and it has an associated metadata store. So we register a new resource type called tenant in the Kubizu server and embed the tenant controller logic inside the Kubizu server. After a new tenant object is created, the tenant controller will first create some system resource on backend cluster, like system namespace, tenant cluster role, and cluster role binding that limits the tenant's permission on the backend cluster. Then the tenant controller will sign certificate and generate kubeconfig for each tenant. We will encode the global unique tenant ID to the common name and organization unit fields in each tenant's certificate. And later, when receiving an HTTPS request from the tenants, the Kubezoo will use the information to decide the sender tenant of the request and convert the request body accordingly. Also, when creating a tenant object, the cluster administrator can specify the tenant's permission, and we will forward each tenant's request to the backend API server with the impersonate header matching the tenant's permission. After tenant is created, we can start processing the request from the tenant. We implement the new REST storage in the gateway server just for converting tenant object. The request forwarding process is shown as in the figure. After receiving a request, the Kubizu server will check if this request is related to the tenant object. If yes, then it is highly possible that the request is sent from the cluster administrator who want to conduct the operation on a tenant object. Otherwise, the request is sent from the tenant, and we will use the information stored in the associated certificate to decide which tenant sent this request. After, we will call the tenant REST storage to convert the object by adding tenant prefix to the object's field based on the object kind. We will talk about the conversion rules in the following slides. Then forwarding the updated request to the backend API server, wait for the response from the backend API server, conduct the conversion process reversely, and finally return the response back to the tenants. Now let's talk about the conversion rules of different tenant objects. For namespace scope object, since it is okay for two objects belonging to two namespaces to share the same name, we only need to add the tenant ID as the prefix to the namespace field. Later, when we want to retrieve objects belong to a specific tenant, we can simply query objects under the corresponding tenant namespace in the backend cluster. For the cluster scope object, we cannot rely on the namespace to provide uniqueness for a resource. Therefore, we add tenant ID as the prefix to the object name. Here are the 25 cluster scope resources of the Kubernetes. We will apply this rule to all of them. Custom resource definition, CRD, is a little bit different from other cluster scope resource. As a custom resource, CRD are organized by group version kind, and the layer name are in the format of pure name followed by the group name. To better organize the CRDs by tenants, we add tenant prefix to the group field. For example, if we have two tenants, tenant 1 and tenant 2, both of them want to create a CRD app with group name tiktok.com, then we will convert the group name to tenant prefix followed by the original group name. Here, we will have tenant 1-tiktok.com and tenant 2-tiktok.com. And then the CRD name will be converted accordingly. Even though we try to standardize the conversion process by divide the resource into different categories, there are still a couple objects need to be handled especially. This kind of object usually include cross-reference, which is a namespace object need to refer to a cluster scope resource. Here is an example. A role binding, which is a namespace scope resource, may refer to a cluster scope resource, which is the cluster role. On the left-hand side, we list all resources that include cross-reference and need to handle especially. Also, all tenants share the same underlying infrastructure. So there are also some objects that are not need to be converted and should be shared between tenants. For example, the resource scheduling related object like priority class, it makes no sense to let a tenant to create a different priority class that has higher priority than other tenants class. On the right-hand side, we list the 3 objects that need no conversion. Okay, that's all for the conversion rules. Next, I will talk about how Kubezoo address some common challenges in the multi-tenancy environment and how Kubezoo supports some classic Kubernetes patterns. First, how Kubezoo ensure the fairness between tenants. Since all tenants will share the gateway server, it can be possible that some greedy tenant may send a large volume of API requests in a very short period of time, which can overwhelm the Kubezoo server and cause slowing down of the request processing of other tenants. To prevent this from happening, we leverage the API server priority and the fairness, aka APF mechanism, which is introduced after the 1.18 alpha. We create independent flow schema and a priority level pair for each tenant, which ensure that different tenants won't affect each other. In addition, by setting the assured concurrency shares of each priority level, we allow cluster administrator to assign different weights to different tenants. For tenant with higher weight, more API requests will be processed. This mechanism should be good enough in most of the case, since the APF has already implemented shuffle sharding, which improves the security and fault tolerance, and the fair queuing, which ensure the fairness between tenants. Kubezoo also support the controller and the operator pattern. Currently, tenants who want to deploy the controller only need to mount the kubeconfig file that point to the Kubezoo server to the controller pod. In the future, we may set the Kubernetes servers host and the Kubernetes servers pod environment variables in a tenant pod directly to make it easier to deploy the controller. Currently, since we use a large flat network internally for all tenants, so we do not need to worry about the network isolation. But if we want to isolate tenant network from each other using VPC, then we may need to ask the underlying infrastructure to support it. For example, we can combine a Kubezoo with some serverless Kubernetes solution, like the virtual kubelets, and the underlying infrastructure will help us to lift the heavy weight and support the network isolation. To support the DNS, we can set up the core DNS as a regular controller in a tenant's VPC with the DNS policy set as the cluster first, and has it watch the tenant's endpoints slice through the Kubezoo server. Then the tenant's pods and the servers should be able to talk to each other within the tenant's VPC. Next, let's see some demo. Okay, I will try to share the screen. Okay. So it looks like I cannot share the terminal.
You should be able to share your entire screen.
Okay.
That's an option.
I need to change the system preference. I'm not sure. Do I need to restart?
Are you on a Mac?
Yeah, I'm using Mac.
Oh, yeah. I think sometimes you have to ask for additional permissions there.
Okay. Yeah, I have to quit and reopen. Is that okay? I have to.
Yeah, sure thing. I'll stand by for you to rejoin.
Okay, I will rejoin in seconds.
Okay, no problem. I want to hear more about the use cases of like what are the tenants, what kind of cross-team communications do they have? Is he there? Hello, Charles, can you hear us?
Yes, I can hear you. Yeah.
Okay, we cannot see you, but we can hear you.
Okay.
Is your camera on?
That's okay. Let me do the demo first, and then turn on
Sure thing.
the camera. Yeah. Entire screen. This one. Okay.
Okay, yeah, I can see your desktop, no problem.
Ignore. Okay. So could you see the terminal clear?
Yes.
Okay.
Yes, again.
Okay, so let's do some demo. So in order to help you better understand a demo, I will first introduce the demo environment. So all the demo will be running on a Minikube cluster locally, and I will start the Kubezoo server and the associated etcd as an independent process on my local machine. Okay. And this terminal in this window, the tmux window, I will use to start all the necessary components. And the next tmux window, I will use to interact with the Kubezoo server to show how we can manipulate or conduct the operation on the tenant objects. So first, let's check the cluster states. Okay, so we have a Minikube cluster up and running locally. And next, let's start the etcd server I use to store the tenants object. So in this demo, I use an independent etcd server, but in a production environment, we can share the etcd server of the backend cluster with different prefix. And then let's start the Kubezoo server. Okay. Then let's go back to the lower right corner. I need to set up the context for the cluster. Okay. So we have two contacts. The first one is the Minikube contacts we use to talk to the backend cluster. And the second contact is the Kubezoo Zoo admin contacts. This one I will use it to talk to the Kubezoo server. So let me make sure the Kubezoo server is up. Yes, it's up. And also I will show some extra resource. So if we check the API resource, on a Kubezoo, we will see that we have an extra API resource called tenants. That is what we use to store the tenant information. And then we will, let's try to create some tenants. So here is a simple tenant YAML I use to create a tenant. So this one is a tenant 2 with the name 62 and ID 62. I just randomly pick the ID and a name. And this one is just for demo, so there are no extra spec. In a production environment, we may add some more spec like quota and the weight for each tenant. And let's check. So I have already created the tenant 1 here, and now I will create a tenant 2. And later I will show how we can isolate the tenant 1 from tenant 2. Okay, so tenant 2 is created. And let's check the backend cluster, see what we have. So as you can see that on the backend cluster, after a tenant created, we will synchronize the system namespace for this tenants. So in our case, we'll synchronize 4 namespace, default, node list, public, and a system with the tenant ID as the prefix. Okay, let's check what we have here as tenant 2, the new tenants we just created. Oh, sorry. So after first we need to get the kubeconfig file for the tenant 2. So after a tenant is created, the Kubezoo server will generate a certificate and also the kubeconfig of the tenant and add it to the annotation of this tenant object. So here we will have the annotation, the kubeconfig file decode in base 64. Let's get to the, okay. So now we can, let me see. Okay. So now let's check what we have on the tenant 2, as tenant 2. So we have no resource for tenant 2. And then let's try to create some pods or stateful sets. Here I create a stateful set. This stateful set is very basic stateful set, which contains 2 replica and 2 pods just do nothing, and 1 headless service. Okay, we have 2 pods created for as tenant 2. Let's check it again. So now, as you can see that 2 pods are created for tenant 2. And if we try to view all these resources as tenant 2, we can see that all these resources are stored in the default namespace as tenant 2. But what if we wanted to, what if the tenant 1 wanted to check the resource on the cluster? So for tenant 1, there is nothing created, so the tenant 1 can see nothing. But what we have, if we try to see this as cluster administrator, so here is what we have. So as cluster administrator, the pods will be created in a corresponding namespace. Here is the tenant ID dash default. And same here, let's create same pods for tenant 1. Okay, so this time let's check the all the resource. So same thing here. So in the tenant 1, we will have the corresponding resource created on the tenant's own namespace. So if we try to do it to see the resource as tenant 2, we will see we can only see the resource belonging to the tenant 2. Okay. So next, I will try to deploy a basic controller. So this basic controller is just a pod lister. I will deploy this controller as tenant 1. This pod lister will just list all the pods inside the default namespace. So if everything works as expected, the pod lister will keep listing 3 pods, including itself and the 2 pods I just created for tenant 1. Okay. Okay, the pod is up and running. So let's check the log. Okay, as we can see here, the pod lister only listed the 3 pods we just created for tenant 1. So we will not be able to see any pods created by the tenant 2. Yeah. Okay, so that's the small demo here. Let's open. Let's go back to the slides. Okay. Just give me 1 second. The slides has been closed.
So just one quick clarification. When you ran the controller, the controller was running as a tenant, right?
Yes, correct. That's the yeah.
And how did it run the kubeconfig? Like doesn't it identify itself as just a regular Kubernetes service account to the API server?
Excuse me, what's your question? I'm sorry.
How did it know to contact the Kubezoo API server as opposed to the actual cluster that it's running on?
Oh, so we mounted the kubeconfig file into the pods.
Oh, okay. Yeah. If you didn't do that, it would just get it from, like, it would just automatically figure out which cluster it's on and get it from
correct.
The node.
Correct.
Okay.
Yeah. So then in the future, we may make it more easier for user to deploy the controller, like setting up the environment variable and mount the server's account token. But for now, we just mount the kubeconfig file. Yeah.
Is there a danger there that somebody could accidentally get access to the real API server by mistake?
In our case, there is no, because the user cannot access the user's kubeconfig file can only be used to access the Kubezoo server. It cannot. Only when if you just render the kubeconfig file to the backend cluster to the users or tenants, then they will be able to access the backend cluster.
Sorry, how can you inject the Kubezoo API server KubeCon in the pod spec if people create a workload and the pod is created in the underlying cluster directly? How can you do that? So are you going to modify the pod template?
Excuse me, what? I'm sorry, I'm trying to open up the slides, so I didn't quite get your question.
Yeah, the question is,
yeah.
I'm not sure how can you inject the proper kubeconfig for pod if the pod is created directly in the underlying.
Oh yeah. So that's a good question. So for now, we just manually. So for example, I'm a tenant 1, and I want to deploy some controllers. So we require the tenants to mount this kubeconfig file
in the template.
Their own, into the pods directly, things like that. So I know this one is just a POC for the controller for now, but we plan to add more support, set the environment variable and mount the server's account token into the pods. Yeah.
Cool.
Yeah. So okay, I think we have finished most of the yes. So that's all for today. Yeah. Any questions?
Yeah, so one question, and by the way, great demo and presentation, seems fairly complete, right? With CRDs as well as you covered DNS and networking and some things. But what about like resource quotas? I think you mentioned quotas can be configured per tenant, but can you elaborate on how that would work?
Yeah, that's a
Sorry, I guess we lost Charles, it looks like, or?
I think he'll be back in a moment.
Okay.
Yeah, one thing I've learned is if you don't use Chrome, the Google Meet is a rough experience.
Because you have to keep finding your tabs and organizing them.
Yeah, it doesn't work as well on Safari.
I use Firefox, and so every time I try to use it on Firefox, it freezes up, and then I'm like, crap, switch to Chrome. So, yeah.
Can't imagine how that might occur. I'm waiting to see. I'm waiting to readmit Charles once he joins, but so far I'm not getting him. Jim, maybe do you want to switch gears and we can talk about your thing at least until about documentation at least until Charles rejoins us?
Sure. All right, yeah, let me just quickly put the link in chat, and I think I added it in the doc. So just in terms of context for this, what we're talking about is, I guess in our last meeting, we had discussed some of the next steps or activities within this working group. And I think the consensus was that, as you know, just like we saw in this demo, there are several good solutions for multi-tenancy. There's projects that have graduated from the working group, but what seems to be still missing right now is in the Kubernetes docs or for beginners, some guidance on what they can use and how they can solve some of these multi-tenancy problems. So the idea was to, what if we start a
Sorry, Jim, wait for Charles rejoin us.
Okay.
Yeah, sorry. I'm not sure which part I at which moment I I was cut off. Yeah.
You were just beginning to answer the question
Oh, okay.
on
The
quotas,
resource quota array. Okay.
but we didn't get the answer.
Okay. Let me answer that. Let me answer the question again.
Okay.
So, so the basic idea is we implement a new CRD called cluster resource quota, which can help us to manage the resource quota across multiple namespace.
Okay.
And the hard limits of this cluster resource quota will be set as the tenant's resource quota, and then the user resource will be the sum of all the resource usage of all the namespace. And we have a controller and also with a webhook, which can help us to admit the incoming paths and also help us to calculate the resource usage across all the namespace. Yes.
Okay, no, that makes a lot of sense. But a couple more questions. One is with managed Kubernetes clusters. Does this impose any problems, or can you use this in front of like GKE, KS, etc.?
Yes. So currently, the only problem is the certificate. So when we wanted to interact with the backend cluster, we need to have the certificate here. We need to have the service account public key because we need to use create some controller inside the Kubezoo. So that thing is not normally accessible if we are using a public cloud provider, public Kubernetes service. That is something we wanted to solve in the future. But for now, other than that, there is no other limitation. I think we can deploy the Kubezoo on public cloud provider as well. Yeah.
So if someone manually gets the certificates using some out-of-band scheme and then applies those, then it would work. But you mean if you just run Kubezoo on like EKS or GKE or AKS, then it requires some manual config for it to work?
Yeah, for now, yes.
Okay, got it. Yeah, one last question. You mentioned something about webhooks, not being supported, but you could run, like if you want to run like, Kyverno or Gatekeeper in the main cluster, you would be able to do that, right? And apply policies and things like that. Is that possible, or were you saying webhooks don't work in the tenant?
Yeah, so right now, because we have not found out the solution that tenants to install a webhook as tenant itself. So if we have multiple tenants, then how can we make sure the webhook only apply to the resource belonging to a specific tenant? Yes.
Okay.
And will it be Kubezoo that actually calls the webhook and enforces it, or will you basically be translating that to something on the underlying API server, just using like namespace labels to limit the application?
So I think the webhook has to be set up on a API server, backend API server.
The real API server, yeah.
And the webhook will talk to the Kubezoo back and go through the Kubezoo again, something like that, and will convert the tenant's object. Yeah.
Right. I just had one question, which is, what's the ongoing maintenance burden of Kubezoo? Like, let's say a new API is added to Kubernetes or an old one's deprecated. Is that all just handled automatically unless there's something like a cross-reference? Okay, so it's a pretty generic front end. There's basically just an allow list of things that you need special attention for, but other than that, it's all pretty pretty common. Cool. Okay.
Yes. Yeah, take us some time to list all these cross-reference objects and the cluster scope object, things like that. I think that's the only thing make the solution may not be that generic. If the Kubernetes add a new object, we need to take some time to investigate if this object need to cross-reference other objects. Yeah.
I think I have one last question. We're almost out of time. I was just wondering if you could tell us maybe a little bit more about the tenants that are actually using these. Like, are these teams that are running services in prod? Like, how often do these services need to talk to each other? Like, you have an integration with DNS, so it sounds like they can talk to each other. But I was just wondering if you could give us any more insight as to the kinds of teams that are using the system.
Oh, so to be clarified, your question is you wanted to know some like the use case of this server, right? Kubezoo server.
Yeah, just a little bit more about the types of tenants that you have. Like, are they all?
Okay.
Yeah.
So tenants can be different. Sometimes we have tenant like small tenant. They just wanted to try out Kubernetes. So they just create a small cluster here and then try out several pods. And sometimes there may be some workloads, online workloads, they wanted to start a cluster in just a minute. And they may just run many pods. And sometimes there may be some offline workloads. They wanted to just submit some machine learning workload, and they wanted to, when they start to submit the workload, they wanted to have a new cluster ready. So that's another use case. So I would say, yeah, there are many use cases we are trying, yeah.
And what about the case where a service or a workload from one tenant needs to access a service from another tenant? Like, when does that come up? Is that usually for like these one-off things as well, like for batch or offline?
So if one tenant service wanted to talk to other tenant service, so in our case, internally, we just use a large flat network. So they can talk to each other freely. So there is no limitation between network connection. Yeah.
Okay, cool. Okay, we're almost at time. So Charles, thanks for that. That was super interesting.
Yep.
Oh, is this open source, or are you thinking of open source?
Yeah, that's the things we wanted to talk. Yeah, we are currently quite ready for the open source, but we are not sure how to make it more natively, because I know that we are no more doing the incubation for the multi-tenancy project, right? So yeah, so maybe in the future, in next month or next month, we will open source this project under the ByteDance or TikTok organization. Yeah, that's the plan.
And then that discussion can feed in well to Jim's discussion, because as we update our documentation, we can decide how we are going to point to community tools that are like Kubernetes, not actually, no, Kubernetes is CNCF, right?
It is CNCF, yeah.
But there are other things like Loft, for example, that are not, and we don't necessarily want to like exclude those and pretend they don't exist.
Right.
So.
Yeah, so real quick on that, and so what we wanted to do was at least propose a section in the Kubernetes documentation on multi-tenancy. So the idea would be to kind of try and come up with some text which serves as an initial guide, explains what different types of models exist, and then provide a way, like Adrian is saying, where we can list projects, both CNCF projects, internal in-tree projects, managed by SIGs, as well as external projects. So there is like a kind of a CNCF policy on how you can list other projects, and Markham so it would be more of a self-service mechanism to update the docs in that manner. But what I was thinking as a next step here, if everyone agrees, is we'll just create a GitHub issue in the multi-tenancy repo, and then we can circulate that and get some feedback from various SIGs and key folks and see what they think, and then propose the doc updates in the sections accordingly. So that was it.
Good.
Yep, I'm +1 on that doc. I think it looks solid.
All right. Thank you. So I'll go ahead and convert it to a GitHub issue and send out a link.
Sounds good.
That's good.
Thanks, everybody. Sorry, I'm afraid I have to go and I'm running the meeting, so that means the meeting is about to end. But thanks, everybody, for joining, and
Thanks.
see you in 2 weeks. Hopefully on Zoom this time. See you later.
Thanks. Bye-bye.
Yeah.
Bye.
See you, bye-bye.